Hey Ash, let's play petang in the evening.
Play petang? Yeah, sure. Let's go.
Assalamualaikum.
Yes? Hey, Dam. Let's play petang with us. Are you free? Petang? I think I'm free today. Here. Two set of ball. Let's play together. Alright, let's go.
What's wrong, Dam?
Wait, let me drink my water first. Hey, Adam Shah. How can you become so skillful in petang?
Nah, man, I just play it every day. Because if you play it every day, then you will become professional like me.
Yeah. I will always follow your words. Let's drink first. Hey, why my water is not cold anymore? Does your water is cold?
Yes, mine's still cold.
I think my tumbler is fake. Do you know why?
I don't know. Let's find out together.
The problem statement. Now, there are two tumblers which can be act as a vacuum flask that can store water in cool or warm temperature in a long time. But these two tumblers show a significant difference in the changes of temperature. Now, our strategy to tackle this problem is by using Newton's law of cooling and warming. Now, Newton's law of cooling and warming state that the rate of change of the temperature of a body is proportional to the difference between the body temperature and the surrounding temperature. Now we are going to move on to the model.
So now let's proceed to the model of Newton's law of cooling or warming. The model is expressed as dt over dt is equals to k times t minus tm. Each of these terms has the definition for itself. Let's go one by one. So for the first term, Tt is equals to temperature of the tumbler at time t. Tm is equals to the temperature of the surrounding tumbler. dt over dt is defined as the rate of change of the temperature. The definition for T minus Tm is equals to the difference between the tumbler's temperature and its surrounding temperature. And for the last term, K is defined as constant of proportionality. So the first step, we have to find the initial value. The general solution is T equals to A times exponent to the power of Kt plus Tm. The temperature of the tumbler at time 0 minutes is equals to 12 degrees Celsius. Then we substitute the value into the equation and we get 12 equals to A times exponent to the power of 0 plus 34.5. The value 34.5 is given in the question, which is the temperature of the surrounding objects. Then we will get the value of A is equals to negative 22.5. Then the general solution for tumbler A is negative 22.5 times exponent to the power of kt plus 34.5. The second step is we find the value of constant k. First, we take the general solution, which is the temperature of the tumbler at time t is equals to negative 22.5 times exponent to the power of kt plus 34.5. Then we insert the time 30 minutes for the temperature of the tumbler, which is the 17 degrees Celsius. Then we substitute the value into the equation. We will get 17 equals to negative 22.5 times exponent to the power of 30k plus 34.5. Then we will get 30k is equals to log 7 over 9. And the value of k is equals to negative 0.0083771. And the last step, we have to find the temperature after 60 minutes. And the general solution is negative 22.5 times exponent to the power of negative 0.0083771 t plus 34.5. We substitute the value 60 minutes into the equation, and we will get negative 22.5 times exponent to the power of negative 0.0083771 times 60 plus 34.5. And the temperature of tumbler A after 60 minutes is 21 degrees Celsius. So now, let's proceed to question 2. Given in the question is tumbler B. The tumbler's temperature is 12 degrees Celsius given at time 0 minutes, and the temperature of the tumbler is 19 degrees Celsius after 60 minutes. But we don't know the temperature of the tumbler after 30 minutes. Given in the question, the temperature of the surrounding objects is 34.5 degrees Celsius. So, the first step is we need to find the initial value. The general equation is T equals to A times exponent to the power of KT plus Tm. Then, the temperature of the tumbler at time 0 minutes is equal to 12 degrees Celsius. We substitute the value 12 into the general equation. We will get 12 equals to A times exponent to the power of 0 plus 34.5, which is the temperature of the surrounding objects. And we will get the A is equals to negative 22.5. And the general equation, the temperature of the tumbler at time t is equals to negative 22.5 times exponent to the power of kt plus 34.5. The second step is we find the value of constant k. We just take back the general solution, which is negative 22.5 times exponent to the power of kt plus 34.5. Then we substitute the value, the temperature of the tumbler after 60 minutes, which is 19 degrees Celsius. Then we substitute the value into the general solution, and we will get 19 equals to negative 22.5 times exponent to the power of 60k plus 34.5. Then we will get 60k equals to ln 31 over 45. Then we will get the value k, which is equal to negative 0.006211. The last step is we find the temperature after 30 minutes. We take the general solution, which is negative 22.5 times exponent to the power of negative 0.006211 t plus 34.5. Then we will get the temperature of the tumbler after 30 minutes is equal to negative 22.5 times exponent to the power of negative 0.006211 times 30 plus 34.5, and we will get is equal to 15 degrees Celsius.
In summary, by using Newton's law of cooling and warming, we can find the product that is more efficient. Tumbler B can store the temperature longer than tumbler A. In conclusion, we can use ordinary differential equation in daily life to solve real-world problems. Application of ordinary differential equation helps popular brands to improve their product quality. By learning ordinary differential equation, we can use it on many different aspects, such as forensic, medical, engineering, and expected the population of certain elements.